A few more things. Magnitude and direction of vector. Again, you may have seen some of this stuff before. If you are given a vector written in terms of Cartesian components, so this is the x component, this is the y component, right? A sub x indicates that this is a component that's along x direction, and a sub y is a component along y direction. Then I can talk about the length of this vector, the magnitude of this vector, by looking at these components, squaring them up, adding them, and then finally taking a square root. And that is called the magnitude of a vector. So that's the definition. So if I know the x and y component, square them up, add them, take a square root, that gives you the magnitude. The unit would be same as the unit of ax and ay. Of course, the x and ay have to have the same unit. They can't be any different. Example, if you have, let's say, force F given as 5i hat plus 6j hat, in Newton, you want to compute its magnitude, square each of these components, add them together, and take a square root, that'll give you the magnitude. You can also find the direction of a vector, okay, and that's easy, because if you have a vector f, and you are given the vector f in terms of x and y component, you know that f sub x would be this, and f sub y would be this, right? This will be the x component, this will be the y component. That's how you write this vector f. Then if you want to get this angle theta, it's a matter of applying the trigonometry. Tan theta would be equal to fy over fx, and if you take the tan inverse of fy over fx, you get the theta. Right? So this is easy to do. You can just take a y component, x component, divide them, and in your calculator punch in tan inverse, and you get your theta, right? Okay, but you have to be careful about this kind of stuff. Why? Because sometimes, if you are not paying attention as to where the vector is pointing in the plane or in the space, you will get the wrong answers. When? So let's first look at the right answer. When do you get it? So let's say f is 3i hat plus 4j hat, right? Where is this vector pointing? Since x and y component, both of them are positive, it has to be in the first quadrant, right? Okay, so how do I get tan theta? Tan theta would be nothing but y component divided by x component, so 4 over 3. Theta would be tan inverse 4 over 3. You punch in the numbers in your calculator, you get theta. Now let's look at another example. So this is minus 3i hat minus 4j hat, okay? If you simply use the definition that I showed in the previous slide, where you divide the y component with the x component and do the tan inverse, the answer you will get is same as this, right? Why? Because minus 4 over minus 3 will cancel the negative sign, and you'll get theta as same as what you have over here. But you know it is wrong. Why? Because this force is pointing in the third quadrant. Why is it pointing in the third quadrant? Because this is minus 3, this is minus 4. Minus 3 means that x component is going that way, and minus 4 means that y component is going that way. And that means force F is over here in the third quadrant. And if you just simply substitute theta as tan inverse 4 over 3, your answer will come out to be something that will be maybe 30 degree, 40 degree. I don't know what the actual number would be. And that will be wrong, because it's not in the first quadrant. This vector is actually in the third quadrant. So what's the difference? Well, the difference is that it's actually 180 degree plus that angle theta, right? So if you draw that vector on the plane, you will clearly see what the direction is. So this is the y component, that's the x component, so that will be the angle. So if you want to give the angle from the positive x-axis, it's easy to do. All you have to do is add 180 degree, because that's the 180 degree, and you'll get your angle, right? Okay, so just be careful about these kinds of things. Magnitude is never a problem, because you square them. So even if it's a negative quantity, it becomes positive. You will never have a square root of a negative quantity. But with the direction, you have to be a bit careful.